So in this screening, we're going to look at how to explore Pythagoras' theorem with area on a right-angled triangle. So the first thing we'll do is just change our settings. We don't need an axis, and if the grid is showing, okay, we don't need a grid. And over here, we're going to construct a right-angled triangle and go down to make sure that you get here more tools. More. Okay, and we're going to use the property that a right-angled triangle is, a right angle is created in a semicircle. So I can create a semicircle here. Might be something you wish to explore later. The idea of why is there a right angle existing in a semicircle. And we're going to create a segment that can be the hypotenuse of our triangle, and any point that we construct on that arc. I'll add a point to the arc. We'll now create a right angle. And I'll go to select, and if I was to move that point C, I will always have a right angle triangle with the right angle at C. Okay, so I don't really need this semicircle, so I'm going to hide that, select, and then look at my settings, and I don't really need to show that object. Okay, so constructing my triangle. I'm now going to construct a area of a polygon, a regular polygon, on each of the sides. Now the order which we select this is going to be important, so we'll try this first method and see what happens. Let's put a five-sided, a pentagon, a regular pentagon on our shape. So we can see here's our regular pentagon, and we'll continue to do that. As you notice, I'm going around from a clockwise direction. If I went in the anti-clockwise direction and put my five-sided shape, I get it in the wrong direction. So I'm just going to undo that, and I'll make sure I select from a clockwise direction. Okay, I now have a pentagon on each side of my right angle triangle. This is my right angle and my hypotenuse. So I'm going to actually just measure the area. And Geogebra is going to help me out there. You might notice I only have 4 significant figures. If I wanted to change that at any time, I could go to settings, and that's not where I find it. Okay, we'll leave that. So I now am interested in, if I can make that larger or smaller, I can see there I've got an area of 130 and 16, and I add those together, that's 146. And in fact, I wonder if that's actually 147. Well, I have a way of adding two things together in Geogebra. So if I go to my poly tool, and in the inset here, I actually want to add these two things together. It's called poly1. So if I just type poly1 and go plus poly2, and I'll notice that's actually called the object O, which will be important. And I can see that actually adds up to 147, which in fact is the same as the area of this poly here. Going back to my tool, I can now actually put some text onto my screen. So the text I'm interested in doing is, what is the area of, actually I want it to be the sum of the area of the two smaller sides. So the polygons on these two smaller sides, and that equals, so I want to add them up. Now to add things up, I go to Advanced, and I go to Geogebra, and I can actually find poly1 plus poly2. Okay, and that will give me an answer, but I want it to actually do my adding up for me, and I know that I stored that as O, so the object O. So let's see what happens when I do that. So now the sum of the two areas is 130 plus 16, which equals 147. And that is the area on the larger side. So I can put here my area of the polygon on the larger side equals, well, that was poly 3. So again, to find that, it's in here in this object. It's poly 3. And there it is, and I can see those two things are the same. Going to select, if I want to now change this polygon on this side, I can actually just go, well, actually, I want that to be a four-sided shape. I want this one also to be a four-sided shape, and this one to be a four-sided shape. And what do I notice? The areas have changed, but actually they're still, when you add them together, the same as the area on the larger side.